Hi and welcome Data Science series lectures. Are you curious about data science and its real world impact? In this session, you will learn what is data science, understanding its role and significance, careers in data science, job roles and industry demands, understanding data, big data, the foundation of data driven decisions, software and installation, setting up essential tools, RMD and YAML, key component of documentations. By the end of this session, you will have a clear understanding of data science fundamentals and the tools needed to explore further. Let's begin this journey. Data science is much more than just analyzing data. It is an interdisciplinary field that integrates statistics, programming, and domain expertise to analyze and extract meaningful insight from data. Core components, data collections, gathering raw data from diverse sources, data cleaning and processing, removing inconsistencies and preparing data for analysis, exploratory data analysis, EDA, identifying trend and patterns, machine learning and AI, developing predictive models, data interpretation and decision making, translating insight into business strategies. Data science is about solving real world problems by transforming raw data into actionable knowledge. This involves collecting data from various sources, cleaning it to remove inconsistency, and analyzing it to uncover patterns and trends. A crucial component of data science machine learning which allows us to develop predictive models that can automate decision making. Companies across industries leverage data science to improve customer experience, enhance operational efficiency, and gain com- competitive advantages. Whether it is recommending moves on Netflix, detecting fraud transaction in banking, or forecasting market trends, data science play a vital role in a modern business and technology. Objective of data science: identifying patterns and trends through statistical analysis, discovering hidden insight in data using statistical techniques, forecasting trends and behavior based on historical data by using machine learning, enhancing business strategies with informed data backed decisions, reducing manual efforts and improving efficiency through AI. The ultimate goal of data science is to extract valuable insight from data and use them to make informed decisions. One major application is predictive analytics, where historical data is analyzed to forecast future events. For instance, in retail businesses, analysis customer purchase history to predict demand and optimize inventory management. Similarly, bank access credit risk using machine learning models. Another crucial aspect is automation, where AI-driven solutions reduce human inventories in repetitive tasks such as chatbots handling customer support or recommendation systems, personalizing user experience. These objectives make data science a critical tool for innovation and efficiency across industries. Career in data science: data scientists develop predictive models and find insights. Data analysis focus on data visualization and reporting. Machine learning engineer design AI models. Data engineer builds scalable data infrastructures. Business intelligence analysis translating data into business strategies. The demand of data professionals has skyrocketed in recent years, making data science one of the most lucrative career paths. A data scientist focuses on applying machine learning techniques to extract insight from large data sets, where a data analysis emphasizes visualizing and reporting. Those with the passion of AI can become machine learning engineers who develop intelligence system for automation and predictive. Additional data engineers create the infrastructure for handling large scale data and business intelligence analysis, convert raw data into strategic insight that drive business decisions. These careers are highly rewarding with opportunities across sectors with such as healthcare, finance, technology, and retail. Essential software installation. Programming language is Python or R, IDE, Jupyter Notebook, RStudio, data science libraries, Pandas, NumPy, Matplotlib, Scikit-learn, and Transfro, big data tools, Hadoop and Spark, and database SQL and NoSQL. Uh, to work efficiency in data science, you need to be familiar with the key programming languages and tools. Python and R are the most commonly used languages due to their simplicity and vast libraries of data manipulation, visualization, and machine learning. Jupyter Notebook and RStudio provide interactive environment for writing and executing code. Additionally, working with database using SQL is crucial for handling structured data. With NoSQL, database like MongoDB are used for unstructured data. In large-scale data projects, Hadoop and Spark help process massive dataset efficiently. Setting up those tools properly in the first step toward the practical data science work. Types of data. Structured data. Data is foundation of data science and it comes in a various form. Structured data is well organized and stored in relational database, where unstructured data includes elements like images and social media posts, and semi-structured is mixture of both. Big data, the five V's. Volume, number one, companies collect terabytes of data from user every second. Velocity, stock market data update every millisecond. Variety, text, audio, images, and sensor data all fall under big data. Veracity, bad data can lead to false prediction and poor decision making. Value, the goal is to turn raw data into useful business intelligence. Big data takes this a step further. It characterized by enormous volume, rapid velocity, and diverse variety. The challenge is working with big data is ensuring veracity, data quality, and extracting value from it. Businesses collect terabytes of data daily from sources like customer interaction, IoT sensors, and financial transactions. Technologies such as cloud computing, distributed storage, and parallel processing has made it possible to handle big data efficiently. Application of data science, real-world use cases, healthcare, disease prediction and personalized treatment, e-commerce, recommendation system and fraud detection, cybersecurity, threat detection and risk assessment, finance, credit scoring and stock market prediction. Marketing, customer segmentation, and sentiment analysis. Data science has transformed numerous industries by enabling smarter decision making. In healthcare, predictive analytics helps diagnose diseases early, while in finance, machine learning models assess credit risk and detect fraud. E-commerce platforms like Amazon use recommendation algorithm to personalize shopping experience. And cybersecurity systems rely on data-driven anomaly detection to prevent cyber threats. Even in sports, teams analyze player performance data to optimize strategies. These real world applications highlight the immense power of data science in shaping industries and improving efficiently. Introduction to R Markdown RMD. R Markdown is a tool for creating dynamic, reproducible report that include code, text, visualization, and equation in a single document. Arc Markdown is a file format that allows you to combine narrative, text, code, and output. It is used in data science, statistics, and academic research to create well-documented reports. The ability to update reports automatically make it highly efficient. It allows users to integrate programming R and Python, documentation Markdown, and output format HTML PDF format in one file. This means that you can write code include inside the document, execute it, and see the result directly below it. Unlike traditional reporting method, R Markdown ensure that results remain consistent every time the report is generated. Key feature of R Markdown: integration of code and text. This feature allows researchers to explain their analysis step by step while showing the actual code used. It eliminates the need of separate code files and reports, making it easy to understand and reproduce results. Without R Markdown, analytics use write separate reports explaining the process manually. With R Markdown, all explanation, code, and results are in one single document, improving clarity. The HTML format is interactive, allowing user to click, zoom, and explore content dynamically. The PDF format is static, ideal for official documents and academic publications. The Word format allows easy editing and useful for business and corporate reports. Output format is selection is doing using YAML headers at the beginning of the file. From next slides, I will explain what is YAML headers. YAML header in Markdown. YAML, yet another markup language. Headers are the mandate section at the beginning of an R Markdown .rmd files. The defined document settings such as title, author, data, output, format, and more. YAML headers are enclosed between the triple dashes. This is the code. Uh, YAML headers define how to document should be structured and formatted before execution. YAML is written in a key value format where each setting is defined on a new line. The output field determines whether the final report will be HTML, PDF, or Word. Key feature of Markdowns are explained in simple table form. YAML allows additional formatting options such as font size, page layout, and automatic tables of contents. To enable a table of contents is an HTML report, modify YAML as follow. Customizing output format. R Markdown allows multiple output formats. You can specify a default format or multiple formats. This is example generating reports in HTML, PDF, Word. The YAML setup generates HTML, PDF, and Word reports from a single .rmd file. The theme United applies a colorful bootstrap theme in the HTML documents. YAML headers can configure R Markdown documents before execution. They allow customization, title, author, data, output format, font size, themes, and table of contents. YAML is simple yet powerful, making R Markdown highly flexible for different types of reports. How to install R Markdown? Install R and RStudio. R is a core programming language and RStudio is the development environment where R Markdown runs. You must run R before installing R Markdown. RStudio provides an easy to use interface with features like syntax highlighting, code execution, and document preview. Install R Markdown packages. The command download and install the R Markdown package, which is required for creating and knitting R Markdown documents. Create an R Markdown documents. Go to File or R Markdown in RStudio. This open a window where you can choose the title, author name, and output format in HTML, PDF, or Word, etc. Choose the output from HTML, PDF, Word. Click Knit to generate the final document. The knit button runs all codes, process the document, and output the final formatted report. If any error, they appear in the console at the bottom of the RStudio. Application of R Markdown. Research documentation. Many universities and research institutions use R Markdown to document, experiment, write reports, and create reproducible studies. Business reports and dashboard. Businesses save time by automatically monthly, quarterly, or yearly reports, reducing manual efforts. Data scientists use R Markdown because it allows them to integrate code analysis and visualization into one document. Report can include statistical models, graphs, and predictive insights. R Markdown is a powerful tool for creating reproducible, dynamic, and well-documented reports. It is used in various fields including education, research, business, and data science. Teams can work together using R Markdown, making document sharing and editing easier. Key takeaway. In this lecture, we have covered the essential concepts of data science, including its definition, objectives, application, and career path. We also explored the tool and techniques used to analyze and process data. As data science continues to evolve, staying updated with the latest trends and tools is crucial. Whether you are interested in machine learning, data engineering, and business analytics, there are numerous opportunities in this field. The best way to learn data science is through hands-on practice, so I encourage you to experiment with dataset, build projects, and stay curious.